Mr. Hassan's Maths channel. I'm now answering question number 8 from the October-November 2009 paper 3 variant 2 9709 Cambridge, and this question is question number 2 for my end of topic worksheet on binomial expansion. Now, part 1 of this question is about partial fractions and part 2 is about binomial expansion. So I'm going to save this video in 2 parts. Both parts I'll put in this end of topic worksheet, but I'll also save it according to this paper, this worksheet, and also I'll have one in my playlist for partial fractions, will be part 1, and part 2 I'll put in the playlist for binomial expansion, which this question is part B is about. So anyway, here we have a fraction, and part 1 tells us to express this in partial fractions. So we have to split this up into 2 separate fractions, okay, into separate fractions. So it's like the opposite of adding fractions together. So when you have something like this, you have 1 plus x over 1 minus x times 2 plus x squared. So we have these 2 factors in the denominator, which we have to split apart. And one of the factors is 1 minus x, which is a linear factor. And the other one is a quadratic factor. It's 2 plus x squared, or x squared plus 2. Okay, so the linear factor, first of all, the first thing we do, we check, is it a proper fraction? The numerator has an order of 1. The denominator has an order of 3. The highest power in the numerator is 1. The highest power in the denominator would be 3. If you expanded it, you have x cubed. So it is a proper fraction because the order of the numerator is less than that of the denominator. So you don't have like a whole number or quotient part, but you have 2 proper fractions. Now, for this to be a proper fraction, it has to have a numerator which is a constant at most. It can't be more than a constant. Because for something to be a proper fraction, the numerator has to be an order less than that of the denominator. So here we have a linear denominator. The numerator has to be a constant. Okay, it's less than linear. And here we have a quadratic denominator. The other factor is a quadratic. So the maximum that the numerator can be is a linear, bx plus c. So I'll call it bx plus c. So I have a over x 1 minus x plus bx plus c over 2 plus x squared. Right? This could be linear, it could be a constant, but it can't be quadratic. So we write it in the highest form it can be. And then now what our objective is to find the values of a, b, and c, and then we can write this in partial fractions. So what I'm going to do now is I'm going to multiply both sides by the denominator of this, the LCM of the denominators, which is 1 minus x times 2 plus x squared. So if you do that, then basically you're left with 1 plus x, and this is identical to, now if I multiply this term by these brackets together, the 1 minus x cancels out, you're left with a times 2 plus x squared. If I multiply this term by these 2 brackets, if I multiply this fraction by these 2 brackets, the 2 plus x squared will cancel out, and you're left with bx plus c times 1 minus x. Alright, so now these 2 have to be, these are identical to each other. These 2 are identical to each other, so I want to find the values of a, b, and c. Now, what we can do here, we can use a variety of methods to get what we need. What I'm going to do first is I'm going to substitute x equals 1 into this whole identity. That will help me because if I put x equals 1 over here, this bracket becomes 0. If this bracket becomes 0, it eliminates this bracket because 0 times something is 0. And I'm left with just the a term. And I can find out what the a term is. So if I put x equals 1, this becomes 1 plus 1. And here I have a times 2 plus 1 squared, which is 2. So I've got 2 equals 3 times a. So therefore a is equal to 2/3. I found the value of a. Now to find the value of b and c. Now to find the value of b, I can't use a substitution here because I can't put anything in this place that will make this bracket become 0. This bracket can never become 0 because it's 2 plus x squared. If I put a negative value in here, it's going to become positive. So I cannot use substitution to get rid of the a part. So what I'm going to do is I'm going to use what's called comparing coefficients. Now the highest form of any term in here is going to be x squared, the whole thing. So if I look at the x squared terms, I'm going to compare the coefficient of the x squared terms. On the left side of this identity, I don't have any x squared term. That means the coefficient of x squared is 0 on this side. And on this side, the coefficient of x squared, well, I'll have, when I multiply this bracket out, I'll have a times x squared, so you're going to have an a. And I'm also going to have bx times minus x. That will also give me an x squared term. Right, so that's going to be negative bx squared, so I'll put negative b. So I know that 0 equals a minus b. I know what a is already, so I can say 0 equals 2/3 minus b. So if I rearrange this, b equals 2/3. So I've got the value of b is also 2/3. Now we need to find the value of c, and I can compare one of the other coefficients, for example, the coefficient of x. I can compare the constant. I think the constant might be a bit easier here, although it doesn't really make much difference. Okay, because I know a and b, so I could use a constant, I can use x term. The constant is probably easier because there's less terms that will give me that. So I'll say, if I compare the constants, I'll have a times 2, which is 2a. Sorry, on this side, the constant is 1. And on this side, the constant on this side is 1. Remember, we're looking at this. This is what we're looking at when we are trying to figure out a, b, and c. So I'm comparing the constants now. On this side, the constant is 1. On this side, I'm going to have 2a. And the other constant will be when I multiply the c by the 1. The c by the 1, that will give me the constant on this. When I expand this bracket, c times 1 will give me the constant. That's going to be plus c. Now I know what a is. A is 2/3. So I'll have 1 equals, that's 2 times 2/3 plus c. And that gives me 1 equals 4/3 plus c. Therefore, c is equal to 1 minus 4/3, which is minus a third. This is 3/3 minus 4 minus a third. So c equals negative 1/3. Okay, so there we have the values a, b, and c, which we can now put back into this. Right, so in the mark scheme for this particular paper, it mentions a is 2/3, b is 2/3, and c is positive 1/3. Now, I've gone through this, checked it many times, and they've made a mistake in what they wrote down as the value of c. However, when they went to part b, or the second part of the question, they've actually used the value of c as negative 1/3 in their steps. So obviously, they've made a misprint in the mark scheme for this part here. Okay, there's no way c is going to be positive 1/3, it's negative 1/3. They've missed out on negative sign, and you can see in part B they've used it as if it's a negative 1/3. So there must have been a misprint there. So if you get confused by that, if you look at the mark scheme for this, I'm pretty sure that this is correct. Okay, so let's put it in the right form so that we can write our answer in a proper fashion. So you have 1 plus x over, and it was 1 minus x over 2 plus x squared. 1 minus x over 2 plus x squared is equal to, and we had a, which I'm going to write here as a over 1 minus x, so a is 2/3. So I'll write it like this first. So you have 2/3 over 1 minus x plus, and then you had bx plus c, which is going to be 2/3 x minus 1/3. So you have 2/3 x minus 1/3 over, and you have 2 plus x squared. Now, obviously, this is not a proper way of writing the answer with these fractions in a fraction. Okay, so you won't get the full marks if you leave your answer like this. What I'm going to do is I'm going to basically write this as 2 over 3 times 1 minus x. Okay, and I'm going to have plus, I'll have 2x minus 1 over 3 times 2 plus x squared. Okay, this 2/3, you can take out 1/3 as a factor, and then that 3 goes in the denominator, and this 3 goes in the denominator. These are the same thing, but this is written in a simplified form. Okay, you can't write your answer like this because you cannot have a fraction inside a fraction and be simplified. It has to be, each part of the fraction should be like a whole number like this. Right, so there is the answer to part 1 of this question. Right, now I'm going to save part 2 in a separate video because I want to save this part of this question under partial fractions, the topic of partial fractions, and part 2 will be saved under binomial expansion. So if you want to find part 2 of the question, just carry on the playlist that you're on, and you will find it if you're looking at the end of topic worksheet playlist, or if you're looking at this particular paper playlist, it will be one of the other questions in the playlist, hopefully the one right after this one. Okay, so that, in fact, I'll put a link to the next video somewhere in the top of the page. So anyway, that concludes this question. Other questions from this paper you can find in the playlist over here. Other questions from this particular end of topic worksheet you can find in the playlist that will appear over here. You can look at my playlist for binomial expansion in this area here, my playlist for partial fractions in this one, and the video for the next part of the question. In fact, I'll put it in the card that will come at the top of the page at the end of the video. Thank you for watching, and see you soon.